Hey, this is Mr. Hanson. We're going to look at trigonometry today. And this is an extension of what you've learned with the Pythagorean theorem. With the Pythagorean theorem, you're just trying to find missing legs or missing side lengths of a right triangle. And we are going to do the same thing today, but this time you won't need two sides to find that third side. You could do it with a side and an angle. So that's kind of what we're looking at. So in front of you, you have two triangles, and something unique, something kind of common to both of these triangles is they're both right triangles, and they both have a 30-degree angle, and so they are going to be similar triangles. If we were to, let's just mark this in red, this length here, and this length here, and let's mark this one in green, this length here, and this length here. Okay, how much bigger is the red hypotenuse than the red short leg? It looks like it's almost about exactly 2 times bigger, and if you can see that, you're right. So let's just say, and what about the green one? Is the green hypotenuse also 2 times as big as the green short leg? And hopefully you can kind of visualize that it is twice as big. So when we compare the short leg, and we'll call this, instead of short, we're going to call it the opposite leg. It's opposite our given angle, opposite our 30 degrees. When we compare that opposite leg to our hypotenuse, will we get the same thing for the red that we do for green? Well, it looks like the hypotenuse is twice as big for the red as it is for the opposite leg, and it looks like we have the same thing again with the green triangle. So there you have it, the same thing. So we're going to use this 30 degrees, because when you have a 30 triangle, no matter what a 30-90 triangle, no matter what the side lengths are, you're always going to have a ratio of 1 to 2 for the red or the green there. So we're going to write sine. Sine just means similar. Sine 30, and this is a trigonometric ratio. Sine 30 is 1 over 2. And if you were to plug sine 30 in your calculator, it would say 1 over 2. Actually, it wouldn't say that. It would say 0.5, which is the same thing as 1 over 2. And that's telling you that the opposite leg is half as long as the hypotenuse for any 30-degree, 90-degree triangle. Now, what would happen if we put a point up here, and so we're kind of extending this a little bit, and this angle here gets to be a little steeper. So what do you think there? And let's do this maybe in blue. So we've got this, and then we've got this. This is no longer a 30-degree triangle. And it looks like as this got bigger, let's say that's maybe 44 degrees or something like that, 42 degrees. Well, let's go 40 degrees. As that angle measure got bigger, if you type in sine 40, it will give you a ratio of the blue to the blue. So I'm going to type it in my calculator, sine 40, and it says 0.64. Oh, let me see if I can do this in black. 0.64. In other words, we have 64 out of 100 here. So changing this angle measure from 30 to 40 degrees, change the ratio of the opposite leg to the hypotenuse. 0.64 is different than 0.50. Now we're saying that for every 100 on the hypotenuse, we go 64 on the long leg. Before we were saying for every 100 on the hypotenuse, we go 50 on the long leg. So this is just a very brief introduction to what sine is. Sine is just a ratio of two sides of a triangle, the opposite side to the hypotenuse. And you can see as sine gets bigger, as the sine angle gets bigger, we get closer and closer to, well, get closer and closer to 1. But we saw that with a 40-degree angle and a 30-degree angle. Thank you.